2025, at exactly 9:18 a.m. Mars local time, NASA's Perseverance rover captured something in the sky above the red planet. The space agency published the image on their official multimedia page. It shows an object circled in green by NASA themselves. This wasn't an amateur photo. This wasn't a conspiracy theorist's blurry screenshot. This was an official NASA image from the Skycam, an upward-facing camera on the top deck of the rover showing something in the Martian sky. 24 hours later, on October 3rd, 7 spacecraft from 4 different space agencies were in perfect position to capture the closest, most detailed images ever taken of the interstellar object known as 3E Atlas. And then complete silence. 4 days of nothing. 4 days while NASA, China, and the UAE released absolutely no data until today, October 7th. The European Space Agency finally broke the silence. They released images. Fuzzy white dots showing a comet with a coma. Normal, unremarkable, exactly what you'd expect to see. But here's what makes their release so disturbing. If ESA's images show something normal enough to publish immediately, why are NASA, China, and the UAE still silent? Why hasn't NASA released the Perseverance images from October 3rd? Why hasn't China, who publishes thousands of Mars images every year and never misses a chance to demonstrate their capabilities, released anything from Tianwen-1? ESA showed us a fuzzy dot and said, "We need weeks or months of analysis." What did the others see that they can't show us at all? Because here's what we know. The math says this object's trajectory shouldn't exist. It has a 1 in a million probability. It's emitting metals in ways that violate basic physics. It's older than our entire solar system. And in 21 days, it will pass behind the sun, completely hidden from every telescope on Earth at the exact moment when solar radiation should either tear it apart or, if certain theories are correct, give it the perfect cover for what happens next. NASA showed us something on October 2nd. 7 spacecraft saw something on October 3rd. ESA showed us fuzzy dots on October 7th. And the agencies with the best cameras, the highest resolution instruments, the most detailed data, they're still not talking. The question isn't what 3 Atlas is. The question is, what did NASA and China see that ESA either didn't see or chose not to mention? If you're as fascinated by this mystery as I am, please like and subscribe to stay updated. Tell me in the comments where you're listening from, what time it is there, and whether you think ESA's release makes this more or less suspicious. And if you want to help grow our community, share this on X, Facebook, Reddit, or your messenger. Thank you for always having our back. Bonus chapter, breaking news update. Before we begin, a quick note. This chapter was added after the original recording was completed. On October 7th, 2025, just hours after we finished the main narrative, the European Space Agency released the first official images and data from the October 3rd Mars flyby. This is breaking news that changes the story significantly. So, we've inserted this bonus chapter to cover what ESA revealed, and just as importantly, what they're still holding back. Let's dive into what we now know. The silence finally breaks. The wait is over. Partially at least. On October 7th, 2025, the European Space Agency did what NASA, China, and the UAE have not. They released images, they published data, they broke the silence that has hung over this story since October 3rd. But here's what makes this both revealing and frustrating. What they released raises as many questions as it answers. And what they haven't released yet might be even more significant than what they have. Let's start with what ISO actually showed us. The ExoMars Trace CAS orbiter using its CASIS camera. The color and stereo surface imaging system captured a series of images between October 1st and 7th. These images have been compiled into an animation, a GIF showing the comet's motion against the background stars. And there it is, 3E Atlas, a slightly fuzzy white dot near the centre of the frame moving downward through the field of view. That's the official description from ESA, slightly fuzzy white dot. Now, before disappointment sets in, let's understand what we're actually looking at and why this observation was extraordinarily difficult. CASIS was designed to photograph Mars. It's optimized for imaging a bright planetary surface from a distance of a few hundred to a few thousand km. It's built to capture geological features, surface textures, color variations in Martian rock and sand. 3 Atlas was 30 million kilometers away. 30 million. That's 100 times farther than CASIS typically observes. And unlike the bright Martian surface, the comet is dim, incredibly dim. Nick Thomas, the principal investigator for the CASIS camera, stated that 3.2 Atlas is approximately 10,000 to 100,000 times fainter than the instrument's usual target. Capturing it at all required 5-second exposures, which for this camera is extraordinarily long. What the images show is not the nucleus itself. At 30 million kilometers, resolving the nucleus, which might only be a few km across, would be like trying to see a mobile phone on the moon from Earth. Impossible with this instrument. What we're seeing is the coma, the cloud of gas and dust surrounding the nucleus. ESA reports the coma measures a few thousand km across. That's substantial. It confirms that 3I Atlas is actively outgassing, releasing volatiles as solar radiation heats its surface. This is normal comet behavior. This is what we expect to see. A comet approaching the Sun develops a coma. The closer it gets, the larger and brighter the coma becomes. The images don't show a tail yet. Comet tails form as solar wind pushes the gas and dust away from the nucleus, creating those spectacular streamers that can extend millions of kilometers into space. But tails are much dimmer than comas. At the time of these observations, if a tail existed, it was too faint for CASIS to detect. ESA notes that the tail might become visible in future observations as the comet continues heating up and becomes more active. So far, nothing unusual, nothing anomalous, just a comet with a coma behaving like a comet should. One might even call it anticlimactic after all the speculation, all the theories, all the waiting. But here's where it gets interesting. Here's where the careful wording in ESA's announcement reveals what they're not saying as much as what they are. Mars Express, ESA's other Mars orbiter, also attempted to observe 3E Atlas, but the comet has not yet revealed itself in these images. The exposure time was limited to half a second, the maximum the Mars Express camera can handle, compared to 5 seconds for ExoMars. That shorter exposure means the comet was simply too faint to register clearly. However, ESA scientists are now working to combine multiple Mars Express images, stacking them together, adding the signal from several frames to bring out the faint comet against the background noise. This is standard astronomical technique. When something is too dim to see in a single image, you take many images and add them up. The signal accumulates, the noise averages out, features emerge. Why are they doing this if the ExoMars images already show the comet clearly enough to confirm it's there, and it has a coma? Why go to the trouble of stacking Mars Express images to extract more data? Because they're looking for something specific, something they hope additional observations might reveal or rule out. Then there's the spectroscopy. ESA attempted to use 3 different spectrometers to analyze the light from 3I Atlas. Mars Express carries Omega and Spy Cam. ExoMars TGO carries Nomad. All 3 instruments were aimed at the comet during the flyby period. Spectrometers don't just take pictures, they break light down into its component wavelengths, revealing the chemical composition of whatever is emitting or reflecting that light. But here's what ESA isn't saying clearly. They're not saying whether they successfully obtained spectroscopic data. The announcement states that at this point it is uncertain whether the coma and tail were bright enough for spectral characterization. Uncertain. Not yes, not no. Uncertain. This matters immensely because if they got good spectra, they know the chemical composition. They know if the nickel signature is there. They know if the carbon dioxide dominance is confirmed. They know if there are unusual elements or compounds that don't fit natural expectations. And if they know, they're choosing not to tell us yet. Choosing to say it's uncertain whether they got the data rather than saying what the data shows. The announcement concludes with a timeline. Scientists will continue analysing the data over the next weeks and months. Weeks and months, not days, not a quick preliminary report, extended analysis, careful examination, taking their time to figure out what 3 Atlas is made of and how it's behaving. So, what has ESA actually given us? They've confirmed the comet exists. They've confirmed it has a coma. They've shown us images that look at first glance entirely consistent with normal comet activity. They've broken the silence just enough to say, yes, we observed it. Yes, it's there. Yes, it looks like a comet. But they've been very careful not to say anything definitive about composition, about unusual properties, about anomalies. Those answers, if they have them, are being held back for further analysis. Now, let's talk about why ESA might have released this. Now, while NASA and China remain silent, there are a few possibilities, and they're not mutually exclusive. First, ESA might genuinely have the least interesting data. ExoMars and Mars Express are capable spacecraft, but their cameras and spectrometers are not as powerful as some of NASA's instruments. NASA's Mars Reconnaissance Orbiter carries higher race, which should have captured much higher resolution images. If those high images show something unexpected, something that requires careful analysis before public release, NASA might be holding back while ESA with less detailed observations feels comfortable publishing. Second, ESA operates independently of the US government shutdown. They're not affected by fur loss or budget disputes or political complications. If they finish their preliminary analysis and determine their data was ready for release, they could simply release it. No bureaucratic delays, no waiting for coordination with agencies that are currently understaffed. Third, and this is speculation, ESA might be putting pressure on NASA and China by releasing their observations. Even if preliminary, they're establishing a baseline. They're saying, here's what we saw, here's what we're willing to share. Now, what about you? It creates public expectation. It makes the continued silence from other agencies more conspicuous. The question everyone should be asking now is this. If ES's images show a normal-looking comet with a normal-looking coma and no obvious anomalies, why are NASA and China still silent? Why hasn't NASA released Perseverance images from October 3rd? Why hasn't China released anything from Tianwen-1? Why is the UAE's Hope Orbiter data still unreleased? ESA has shown us that yes, observations were made and yes, they can be published. So, what's stopping the others? Colin Wilson, ESA's project scientist for Mars Express and ExoMars, made an interesting comment in the announcement. He said, "It's always extra exciting to see the orbiters responding to unexpected situations." Unexpected. That's a curious word choice. 3 Atlas was predicted months in advance. Its flyby was scheduled. Spacecraft were positioned deliberately to observe it. What part of this was unexpected? The trajectory wasn't unexpected. The arrival date wasn't unexpected. The basic fact of an interstellar comet passing Mars wasn't unexpected. So, what does unexpected refer to? The behaviour, the appearance, something in the data that didn't match predictions? We're reading tea leaves here, analysing word choices, looking for hints in what's said and what's carefully not said, because that's all we have. Gave us fuzzy white dots and careful language and a promise of more analysis in the coming weeks and months. The silence has broken, but it's broken in the most limited way possible. Just enough to confirm observations happened. Just enough to show normal comet appearance. Just enough to make the continued silence from NASA, China, and the UAE even more conspicuous than before. Whatever they saw, whatever those other spacecraft captured, it's still being held back. And ESA's release, rather than answering questions, might have just made the most important question more urgent. If what ESA showed us is unremarkable enough to publish immediately, what did the others see that requires weeks or months of analysis before anyone can talk about it? Chapter 1. The 9 spacecraft that hold the truth. Let's start with what we know for certain. On October 3rd, 2025 at 400 Coordinated Universal Time, the interstellar object designated 3RI Atlas reached its closest approach to Mars. The distance was 29 million kilometers. In astronomical terms, this is extraordinarily close. Close enough that we had an unprecedented opportunity. An opportunity that happens perhaps once in a human lifetime. 7 spacecraft were positioned around Mars at that exact moment. 7 sets of instruments, 7 different vantage points, 4 different space agencies, all aimed at the same target, all capturing data at the same time. The first is NASA's Mars Reconnaissance Orbiter, launched back in 2005 and still operational after 2 decades in Mars orbit. Its crown jewel is the HIRI camera, the high-resolution imaging science experiment. This camera is capable of resolving objects down to 30 centimeters from Mars orbit, but for 3 Atlas positioned 30 million kilometers away, the resolution would be approximately 30 kilometers per pixel. That might not sound impressive until you realize something crucial. This is the highest resolution image of an interstellar object that has ever been possible. Ever in the entire history of human astronomy. Think about that for a moment. Every other interstellar visitor we've detected, Umafu Amura in 2017, Borisov in 2019, we only managed to capture them as they were leaving as distant points of light already racing away from us. But 3E Atlas, we've been tracking it since July. And on October 3rd, we had the perfect shot. The second spacecraft is the European Space Agency's Mars Express. Launched in 2003, it carries the high-resolution stereo camera, designed primarily to map the Martian surface in 3 dimensions. But cameras don't care what they're pointed at. Mars Express has the capability to create 3-dimensional structural maps of the comet's coma. The cloud of gas and dust surrounding its nucleus, it could reveal the shape, the density distribution, the asymmetries in the outgassing patterns. The third is another European spacecraft, the ExoMar Trace Gas Orbiter, a joint mission with Russia's Roscosmos. This one carries Nomad, the Nadir and Occultation for Mars discovery instrument, and CASAS, the color and stereo surface imaging system. Nomad is a spectrometer designed to detect trace gases in Mars' atmosphere with incredible sensitivity. But when you point a spectrometer at a comet, you're looking at something far more interesting than Martian air. You're analyzing the chemical composition of material that formed in another star system billions of years ago, in conditions we can barely imagine. Then there's NASA's Mars Odyssey Orbiter, launched in 2001, making it one of the longest operating spacecraft at Mars. Its Themis instrument, the Thermal Emission Imaging System, captures infrared data. It measures heat signatures, and if 322 Atlas was experiencing any unusual thermal activity, any unexpected energy output, any hotspots that shouldn't be there, these would detect it. The 5th spacecraft is one we've already mentioned. Perseverance, the rover sitting on the Martian surface in Jezero crater. Its Skycam mounted on the top deck already captured something on October 2nd. But what about October 3rd? What about the moment of closest approach? Perseverance has multiple cameras. It has spectroscopy equipment. It was the only ground-based observer with a direct line of sight. The 6th spacecraft is China's Tianwen-1 orbiter, And this is where things get interesting in a very different way. Tianwen-1 has been at Mars since February of 2021. In that time, the China National Space Administration has released over 14,000 images from the mission. 14,000. They publish regularly. They publicize their achievements. Space exploration is a matter of national pride, and China uses every opportunity to demonstrate their capabilities to the world. But for 3 ESA Atlas, nothing. Complete silence. Not a single image. Not a single data release. Not even an acknowledgement that they attempted observations. The 7th is the United Arab Emirates Hope Orbiter, also known as the Emirates Mars mission. Hope carries the Emirates Mars infrared spectrometer designed to study the Martian atmosphere, but perfectly capable of gathering spectroscopic data on a passing comet. The UAE has been remarkably transparent with their mission data. They've shared images, they've collaborated internationally, they've made their findings publicly available. But for 3 Atlas, also silent. Now, here's where we need to talk about what comes next, because this story isn't over. It's barely begun. In late November, between the 2nd and the 25th, the European Space A's JUICE spacecraft, the Jupiter Icy Moons Explorer, currently on its way to the outer solar system, will have its instruments trained on 3I Atlas. JUICE will observe the comet after its closest approach to the Sun. After perihelion, when it's at its most active, when the solar heat has triggered maximum outgassing, when if anything unusual is going to happen, it will be happening. But here's the problem. JUICE is currently in a position relative to the Sun that creates a communication challenge. The data it collects in November won't be transmitted back to Earth until February of 2026. 4 months of waiting. 4 months of wondering what JUICE saw. And then there's the possibility, still under consideration, of redirecting NASA's Juno spacecraft for a close encounter in March of 2026. Juno is currently in orbit around Jupiter, studying the gas giant's atmosphere, magnetic field, and interior structure. But Juno has fuel. It has functioning instruments. And 3-2 Atlas will pass within approximately 54 million kilometers of Jupiter on March 16th, 2026. A trajectory change in September of this year could position Juno for a flyby at roughly 25 million kilometers. That's closer than the Mars encounter. That's close enough for detailed imaging. Close enough for spectroscopy that could finally answer some of the questions that are keeping astronomers awake at night. But NASA hasn't approved the maneuver yet. And with the current government shut down, with 15,000 NASA employees furled, with the agency essentially paralyzed, that decision is frozen in bureaucratic limbo. So we have 7 spacecraft that observed the October 3rd flyby. We have 1 spacecraft that captured preliminary images on October 2nd. We have future observations planned for November and potentially March of next year. And out of all of this, out of all these instruments, all these agencies, all this data, what has been released to the public, 1 image from Perseverance's SkyAM taken on October 2nd, published on NASA's raw image page, showing something in the Martian sky circled in green, and then nothing. Chapter 2, the Perseverance SkyCam images, October 2nd. Let's talk about what NASA actually published, because this isn't speculation. This isn't rumour. These are official images from NASA's Mars 2020 Raw Image Archive. They exist. They're time-stamped. They're labelled. And anyone with an internet connection can go look at them right now. The image was captured on Sol 1642. That's the Martian day count since Perseverance landed in Jezero crater. Sol 1642 corresponds to October 2nd, 2025 Earth time. The exact timestamp is 091848 Mars local mean solar time. Morning on Mars. The sun had been up for about 3 hours. The camera that captured this image is officially designated as the Perseverance SkyCam. Is mounted on the top deck of the rover, the flat surface where most of the scientific instruments sit. Unlike the navigation cameras or the mast-mounted cameras that face forward and scan the horizon, the Skycam points straight up. It's designed to observe the Martian sky to track atmospheric phenomena, dust devils, clouds, the changing opacity of the atmosphere as dust storms develop and dissipate. But on October 2nd, it captured something else. The first image shows what appears to be a circular structure, somewhat distorted by the camera's wide-angle lens. There's a distinct object visible in the upper portion of the frame. NASA's own image processing team circled it in green. Let that sink in for a moment. This isn't an amateur astronomer drawing attention to a blurry pixel. This is NASA's official multimedia page, with an annotation added by NASA personnel highlighting something in the Martian sky. The second image is wider, showing more of the Skycam's full field of view. You can see the circular housing of the camera itself in the frame, the characteristic fisheye distortion at the edges. And there in the upper right quadrant, the same object appears. It's faint, but it's there. Is not a dead pixel, is not a cosmic ray hit, is not a processing artifact. It moved between frames, which means it has actual motion relative to the camera. Now, here's what makes this technically significant. The Skycam is not a high-resolution instrument. It's designed for wide-field monitoring, not for detailed imaging of distant objects. Its purpose is atmospheric observation, tracking phenomena that happen in the Martian sky at relatively close range. The fact that it picked up 3i Atlas at all tells us something important. It tells us the object was bright enough to register on a camera not designed for astronomy, bright enough to stand out against the Martian daytime sky, which, despite being much dimmer than Earth's sky due to Mars' thin atmosphere, is still nowhere near the darkness of night. This wasn't captured during a Martian evening or pre-dawn twilight. This was mid-M morning, and yet there it is. The distance at the time of this image was approximately 30 million kilometers. That's the separation between 3i Atlas and Mars on October 2nd. For comparison, that's about 80 times the distance between Earth and the Moon, is a vast gulf of empty space. And Perseverance's upward-facing camera, with no particular expectation of capturing anything except Martian weather, caught it. But here's where the timeline becomes crucial. October 2nd was not the closest approach. That happened 24 hours later on October 3rd. The object was still incoming, still approaching, still getting brighter as it came nearer to Mars. So the question becomes, what did Perseverance capture on October 3rd? We don't know because NASA hasn't released those images. The raw image archive for Perseverance is usually updated within a few days of image acquisition, sometimes within hours. The rover takes thousands of photos. They get downlinked to Earth via the Mars orbiters, which serve as relay satellites. The data arrives at the Deep Space Network stations in California, Spain, and Australia. It gets routed to the Jet Propulsion Laboratory in Pasadena, and then it gets uploaded to the public archive. This process is mostly automated. It doesn't require a human to decide what gets published and what doesn't. The images just flow through the pipeline and appear on the website. It's been working this way for years. Curiosity's images appear like clockwork. Perseverance's images appear like clockwork, except apparently not the images from October 3rd, not the images from the moment of closest approach, not the images that would show us what 3 Atlas looked like when it was at its nearest point to Mars, when it was at its brightest, when it was the most observable it has ever been or ever will be from any human-made camera. Those images are missing. Now, one might argue that Perseverance was busy. It's a working rover. It's in the middle of a mission to collect rock samples, to study Martian geology, to search for signs of ancient microbial life. It has a schedule. It has priorities. Maybe the science team didn't task it to observe 3 Atlas on October 3rd. Maybe they were focused on drilling another core sample or navigating to a new location. Except we know that's not true because we know from the official mission plan that multiple spacecraft were coordinating observations of 3I Atlas during its Mars flyby. We know that this was considered a significant event. We know that NASA publicly stated they intended to observe it, and we know that Perseverance has multiple cameras that could have been aimed skyward at any point during the Martian day on Sol 1643, which corresponds to October 3rd. The rover doesn't need to stop working to take a picture of the sky. It can do both. The Skycam is always on. It's always pointing up, is always ready to capture whatever passes overhead. So, where are the images? There's another detail worth examining. The image from October 2nd was not highlighted or featured prominently by NASA. It wasn't released with a press statement. It wasn't included in any mission updates or news articles. It simply appeared in the raw image archive as thousands of other images do with basic metadata and no commentary. The green circle annotation was added later, presumably when someone browsing through the archives noticed the object and flagged it. NASA's multimedia team often adds annotations to interesting images, pointing out features of geological interest or unexpected atmospheric phenomena. It's standard practice. But the timing here is interesting. The annotation appeared, the image started circulating on social media, and then the silence began. One might also wonder about the orbiter images because Perseverance wasn't the only camera pointed at 3 Atlas that day. Mars Reconnaissance Orbiter was overhead, Mars Express was in position, Odyssey was active. The orbiters have far more powerful cameras than a rover's Skycam. They should have captured dramatically better images. And perhaps they did. We just haven't seen them. There's a pattern emerging here, and it's not a subtle one. On October 2nd, one day before closest approach, an image appears showing 3I Atlas in the Martian sky. It's published automatically as part of the standard data pipeline. Someone notices it, someone annotates it. It starts generating interest. And then on October 3rd, the day of closest approach, when 7 spacecraft are observing simultaneously, when we should be seeing the best images ever captured of an interstellar object, nothing is released. Not from Perseverance, not from Mars Reconnaissance Orbiter, not from Mars Express or Odyssey or any of the others. The automatic data flow seems to have stopped flowing. Or perhaps more accurately, it's being held back because data doesn't just disappear. It exists somewhere, on hard drives at the Jet Propulsion Laboratory, on servers at the European Space Operations Centre, in archives at the China National Space Administration. It exists. We're just not being allowed to see it. Now, why would that be? Why would NASA publish an image on October 2nd and allow it to be annotated and shared, and then withhold everything that came after? There are really only 2 possibilities. The first is mundane technical issues, data corruption, communication glitches, the government shutdown affecting normal operations. Maybe the images are sitting in a queue somewhere waiting to be processed by furrowed employees who aren't currently at their desks. Maybe there's a perfectly reasonable explanation that has nothing to do with what the images actually show. The second possibility is less mundane. The images show something unexpected, something that requires careful analysis before public release, something that perhaps multiple space agencies need to discuss and coordinate on before anyone says anything to anyone else. The image from October 2nd shows us an object in the sky, a dot of light, nothing more. But dots of light don't require coordination between NASA, ESA, CNSA, and the UAE. Dots of light don't require silence. Dots of light get published automatically, analysed by the scientific community, and discussed openly in academic papers and press releases. So, what did the camera see on October 3rd that a dot of light on October 2nd didn't prepare anyone for? What changed in those 24 hours as 3I Atlas came closer and the resolution improved and the details became clearer? We don't know, but 7 spacecraft do, and 4 space agencies do, and somewhere in secure facilities on 3 continents, people are looking at images that we're not allowed to see. Chapter 3. 4 Days of Silence. What happened after today is October 7th, 2025. It has been exactly 4 days since the closest approach, 96 hours since 7 spacecraft observed 3I Atlas at the most detailed resolution ever achieved for an interstellar object. And in those 96 hours, the silence from the world's space agencies has been, to put it mildly, deafening. Let's establish what normal looks like. Because to understand why this silence is significant, you need to understand how far it deviates from standard operating procedure. When Mars missions capture interesting data, it gets released quickly. NASA's Mars Reconnaissance Orbiter regularly publishes high-res images of the Martian surface, often within days of acquisition. These aren't just routine mapping photos, these are high-resolution observations of dust devils, avalanches on crater walls, newly formed impact craters, seasonal changes in the polar ice caps. The images appear on NASA's website with explanatory captions. They get featured in press releases. They get shared on social media by NASA's Public Affairs Office. The European Space Agency does the same with Mars Express. When the spacecraft captures something notable, a dust storm, a mineral deposit, an unusual geological formation, ESA publishes it. They write articles. They provide context. They invite planetary scientists to comment. The information flows outward to the public as a matter of routine. But here's where it gets really interesting. China's approach to space achievement is, if anything, even more aggressive in terms of publicity. The China National Space Administration views space exploration as an extension of national prestige. Every successful landing, every orbital insertion, every scientific discovery is an opportunity to demonstrate technological capability to the world. When Tianwen-1 entered Mars orbit in February of 2021, CNSA released images within hours. When the Zhurong rover landed on the surface in May of that year, the images came immediately. High resolution, color-corrected, professionally processed. Since Tianwen-1 arrived at Mars, CNSA has released more than 14,000 images from the mission. 14,000. That's an average of nearly 12 images per day for 4 years straight. They show the Martian surface, the rover's tracks, rocks, dunes, the Chinese flag painted on the lander. They show everything because showing everything demonstrates that China can compete with NASA and ESA on equal terms. So when 3 Atlas, the most significant interstellar object to pass through our solar system in recorded history, came within 30 million kilometers of Mars, what did CNSA release? Nothing. Not one image. Not one dataset. Not one press statement. Not even an acknowledgement that Tianwen-1 attempted observations. This is not normal behavior for CNSA. This violates every pattern they've established over 4 years of Mars operations. If TN11 had captured images of 3I Atlas, and if those images showed exactly what everyone expected to see, a typical comet with a typical coma and a typical tail, CNSA would have published them instantly. They would have celebrated capturing an interstellar visitor. They would have used it as evidence of their advanced imaging capabilities. They would have, in all likelihood, beaten NASA to the punch and released their data first just to demonstrate that China got there before America did. But they didn't. They went silent. Completely, utterly silent. Now, one might argue that the United States government shutdown explains NASA's silence. And to some extent, that's a fair point. As of October 1st, 2025, more than 15,000 NASA employees were furloughed. That's 83% of the AY's workforce. The Jet Propulsion Laboratory, which manages most of NASA's Mars missions, is operating with a skeleton crew. Data processing pipelines that normally run smoothly are now running through bureaucratic molasses. But here's the problem with that explanation. The government shutdown only affects the United States. It doesn't affect the European Space Agency. It doesn't affect the China National Space Administration. It doesn't affect the United Arab Emirates Space Agency. These are independent organizations on different continents with different funding structures and different political situations. ESA's budget comes from member states of the European Union. CNSA answers to the Chinese Communist Party. The UAE's space program is funded by the Emirati government. None of them are subject to American budget disputes. None of them have furloughed employees. None of them have any operational reason to delay releasing data about 3 Atlas. And yet is silent. CNSA is silent. The UAE is silent. This is where we need to talk about what coordination looks like in the space community, because these agencies do not coordinate on everything. In fact, they rarely coordinate on much of anything beyond basic safety protocols and frequency allocation to avoid interfering with each other's communications. NASA and CNSA in particular have a relationship that can best be described as competitive. Not hostile, but competitive. There are legal restrictions on cooperation between American and Chinese space programs. The Wolf Amendment passed by the US Congress in 2011 prohibits NASA from using federal funds to cooperate with China on space activities without explicit congressional approval. This means that NASA and CNSA do not share data freely. They do not collaborate on joint missions. They do not coordinate their scientific announcements. They compete. They watch each other. They try to outdo each other. When China lands a rover on the far side of the moon, NASA responds by accelerating its Artemis program. When NASA lands Perseverance on Mars, China responds by landing Zhurong. This is the dynamic. This is how it works. So when NASA and CNSA both go silent about the same event at the same time, that's not normal competition. That's coordination. That's something else entirely. The same logic applies to ESA. While ESA and NASA do collaborate on many projects, they're still separate entities with separate priorities. When ESA has interesting data, they publish it independently. They don't wait for NASA's permission. They don't check with Washington before releasing Mars Express images. They operate autonomously. But not this time. This time, ESA is silent while NASA is silent, while CNSA is silent, while the UAE is silent. 4 agencies, 4 different continents, 4 different political systems. All staying quiet about the same event. There's a phrase that applies here. When everyone talks, nobody listens. When everyone stays quiet, everyone hears the silence. Think about what it would take to achieve this. Think about the conversations that would need to happen. NASA officials reaching out to ESA counterparts. ESA reaching out to CNSA. Someone coordinating with the UAE agreement that nothing gets released until what exactly? Until everyone has had time to analyze. Until everyone agrees on what the data means. Until everyone decides how to present it to the public. These are not conversations that happen for routine observations. These are not conversations that happen for a typical comet passing through the solar system. These are conversations that happen when something unexpected appears in the data, and nobody wants to be the first to say it out loud. There's a pattern in how scientific anomalies get handled. When something strange shows up in data, the first instinct is not to publish immediately. The first instinct is to check, to verify, to make absolutely certain that what you're seeing is real and not an instrument glitch or a processing error or a cosmic ray event that happened to look unusual. So you run diagnostics, you reprocess the data, you compare it against calibration standards, you ask colleagues to take a look, you very carefully and very methodically rule out every possible mundane explanation before you even consider the possibility that you might be looking at something genuinely anomalous. This is good science. This is how it should work. The problem is, it doesn't usually require 4 independent space agencies to coordinate their silence while they're doing it, unless perhaps they all saw the same anomaly, unless they all need to verify it, unless they all need to be absolutely certain before anyone says anything, because once it's said, it can't be unsaid. So, here we sit, October 7th, 4 days after the closest approach. The data exists somewhere in JPL's servers, somewhere in ESA's archives, somewhere in CNSA's databases, somewhere in the UAE's mission control systems. There are images, high-resolution images, spectroscopic data, thermal readings, everything the 7 spacecraft captured during those critical hours when 3i Atlas was at its nearest point to Mars. And none of it, not one byte, has been shared with the scientific community or the public. The October 2nd SkyM image remains the only visual evidence we have. A dot of light in the Martian sky, 1 day before closest approach, 1 day before the resolution improved by orders of magnitude, 1 day before whatever it was that made 4 space agencies decide they needed to stay quiet until they figured out what they were looking at. The silence continues, and with each passing day, the silence itself becomes the loudest statement anyone is making. Chapter 4, what it actually could be, the theories. While we wait for space agencies to break their silence, let's talk about what 3E Atlas might actually be, because the answer to that question determines whether we're witnessing a routine astronomical event or something that will fundamentally change humanity's understandings of its place in the universe. There are 4 primary theories being discussed right now, ranging from the mundane to the extraordinary. Each has evidence supporting it. Each has problems. And understanding all 4 is essential to grasping why the silence from those who've seen the October 3rd data might be so carefully maintained. Theory 1, the ancient scout ship. This idea has been gaining traction in certain corners of the internet, and while it sounds like science fiction, the mathematics behind it are surprisingly sound. The theory goes like this. 3 Atlas is not a natural object. It's a probe, a spacecraft launched by an intelligent civilization somewhere in the Milky Way between 7 and 14 billion years ago. To put that in perspective, our Sun is only 4.6 billion years old. Earth is 4.5 billion years old. The first complex multicellular life on Earth appeared roughly 600 million years ago. Humans, anatomically modern humans, have existed for maybe 300,000 years. But 3.2 Atlas could be older than all of that. It could have been constructed and launched when the universe was less than half its current age, when our solar system didn't exist, when the materials that would eventually form Earth were still scattered across interstellar space in nebular clouds. Why would a civilization build something like this? The hypothesis suggests it's an observational probe, a recorder, a device sent out to travel the galaxy to document cosmic events, to collect data across geological timescales, not a ship with a crew, not something expecting to return, but an automated system perhaps powered by something we don't understand, perhaps dormant for billions of years and only activating when it encounters something worth observing, like a solar system, like planets in a habitable zone like us. Some variations of this theory propose that 3 Atlas is an interstellar arc not carrying living beings but carrying information, knowledge, technology, the preserved legacy of a civilization that knew it was dying and wanted something of itself to survive. A message in a bottle thrown into the cosmic ocean billions of years ago, now washing up on our shore. The timing is interesting. 3i Atlas would have entered the outer boundaries of our solar system approximately 8000 years ago. That's roughly when human civilization began keeping written records, when the first cities were built in Mesopotamia, when agriculture transformed nomadic tribes into settled societies. If you're a civilization designing a probe to observe a developing intelligent species, You might program it to arrive at this stage, not so early that there's nothing interesting to see, not so late that you miss the crucial transition period. This is the theory that frightens some people because if it's true, we're being watched. We have been for millennia and we didn't know it. Theory 2, active reconnaissance mission. This is similar to Theory 1, but more immediate, more purposeful. Instead of an ancient relic drifting for billions of years, this theory proposes that 3E Atlas was deliberately sent to our solar system relatively recently, perhaps within the last few million years by a civilization that detected our sun and wanted a closer look. The trajectory supports this. The object isn't just passing through randomly, it's aligned almost perfectly with the ecliptic plane. The flat disk where all the planets orbit is timed to pass close to multiple worlds, Mars in October, Jupiter in March. If you were designing a reconnaissance mission to sample different planetary environments, to observe different types of worlds within a single system, this is exactly the trajectory you would choose. The retrograde orbit is another piece of evidence. 3 Atlas is moving opposite to the direction the planets orbit. This is actually advantageous for a reconnaissance mission. As the object moves through the solar system, the planets come to it. If it wanted to deploy smaller probes, smaller observation devices, the retrograde motion means those probes could be released with minimal energy expenditure and still intercept planetary orbits. The planet's own orbital velocity does half the work. A lobe. The Harvard astrophysicist who's been following this object closely has described it as a potential cosmic flyby reconnaissance mission. Not necessarily hostile, not necessarily friendly, just observational. A civilization conducting a survey gathering data about planetary systems across the galaxy, and we happen to be one of the stops on the itinerary. Theory 3, natural comet with exotic chemistry. This is the mainstream explanation, the one most astronomers favour by default. 3 Atlas is a comet. Just a comet. It formed in another star system billions of years ago, got ejected by gravitational interactions with planets or passing stars, and has been wandering into stellar space ever since. Now it happens to be passing through our solar system. Nothing intelligent about it, nothing designed, just a chunk of ice and rock and frozen gases doing what chunks of ice and rock and frozen gases do. The unusual chemistry explained by formation conditions we don't see in our solar system. 3 Atlas likely came from the Milky Way's thick disk, a region of older stars with different metallicity, different elemental abundances, different conditions during planetary formation. Comets that form in those environments might have different compositions. More carbon dioxide, less water, different metal ratios, different volatiles. Strange, but not impossible, just different. The trajectory, a statistical coincidence. Yes, the odds are low, but low odds aren't the same as 0 odds. In a galaxy with hundreds of billions of stars, each potentially ejecting comets into interstellar space, eventually, one of them is going to have a trajectory that looks suspiciously purposeful just by random chance. This might be that one. This theory has the advantage of not requiring any extraordinary assumptions. No ancient civilizations, no technological artifacts, no intelligence. Just nature doing what nature does, creating objects with a vast range of properties, and occasionally one of them looks weird enough to make humans wonder. Theory 4, the hybrid stealth craft. This is the most creative of the theories, and it's been proposed by people thinking about how an advanced civilization might camouflage technology. The idea is simple, but elegant. Don't build an obviously artificial spacecraft. Instead, find a natural object, an asteroid or comet, and hollow it out. Use the natural rock and ice as a shell as camouflage while hiding your actual technology inside. From the outside, it looks like a comet. It has a coma because you're venting gases deliberately to maintain the illusion. It has outgassing patterns that seem natural because you're engineering them to seem natural. Any telescope pointed at it sees exactly what it expects to see. A comet. Just a comet. Nothing unusual. But inside there's structure. There's machinery. There's purpose. This theory explains a lot. It explains why 3 Atlas might show some comet-like behaviours while also displaying anomalies that don't fit the comet model. It's both. It's a comet exterior wrapped around a technological core, the perfect disguise for interstellar travel. You don't attract attention. You don't trigger alarm. You pass through solar systems looking like harmless debris while conducting whatever mission you were designed to conduct. The hypothesis has been seriously considered in astrobiology circles. If humans ever build interstellar probes, we might use this exact strategy, mining an asteroid or comet for raw materials, using it as both resource and camouflage. It's efficient, it's smart. And if we can think of it, another civilization could have thought of it first. So these are the 4 theories: ancient artifact, active reconnaissance, natural comet, camouflage technology. Each has supporting arguments, each has adherents. Each leads to very different conclusions about what we should do next. And somewhere in secure facilities where the October 3rd data is being analysed, people are looking at images and spectroscopy and thermal readings and trying to figure out which of these theories the evidence supports. Or perhaps they're looking at data that doesn't fit any of these theories. Perhaps they're seeing something nobody expected. Something that requires them to develop a 5th theory, a 6th theory, something that hasn't been publicly discussed because nobody imagined it was necessary. We can speculate. We can theorize. We can build models and run probabilities and debate online, but the people who know, the people who've seen what 7 spacecraft saw on October 3rd, they're not talking. Not yet, not to us. And that silence, more than any theory, tells us that whatever 3i Atlas is, it's important enough to be very, very careful about how the answer gets revealed. Chapter 5. The 1,000,001 Mathematical Impossibility. Let's talk about numbers. Not the comfortable numbers we use in everyday life, but the uncomfortable ones that make astronomers sit up and start asking questions they're not sure they want answered. 3 Atlas is on a trajectory that shouldn't exist. Not can't exist, but shouldn't exist. The distinction matters. There's nothing physically impossible about its path. It doesn't violate any laws of motion. It doesn't break orbital mechanics, but the probability of this trajectory occurring by random chance is so vanishingly small that calling it unlikely feels like calling the Pacific Ocean damp. Here's what we're dealing with. On October 3rd, 2025 3i Atlas passed within 29 million kilometers of Mars. On March 16th, 2026, it will pass within 54 million kilometers of Jupiter. 2 planetary encounters, 2 of the most scientifically interesting worlds in our solar system after Earth, both in a single flyby, both at distances close enough for detailed observation. Let's break down why this is mathematically extraordinary. First, the orbital plane alignment. The ecliptic plane is the flat disk where Earth and the other planets orbit the Sun. It's the reference plane for the solar system. If you imagine a solar system as a venal record, the ecliptic plane is the surface of that record, and the planets are grooves spiraling around the center. Most comets and asteroids that belong to our solar system orbit roughly in this plane, give or take a few degrees, because they all formed from the same rotating disk of material billions of years ago. 3IA Atlas is inclined at 4.89 degrees relative to the ecliptic. That doesn't sound like much. Less than 5 degrees nearly aligned. But here's the thing. For an interstellar object, for something coming from outside the solar system with no connection to our formation history, there's no reason it should be aligned at all. It could come from any direction. Above the ecliptic plane, below it, perpendicular to it. The vast majority of possible trajectories through three-dimensional space would bring it nowhere near the ecliptic. The probability of that timing working out about 0.02% 2 in 10,000. Now, here's where it gets truly uncomfortable. These probabilities are independent. The alignment with the ecliptic plane and the timing of the planetary encounters are separate factors. To get both, you multiply the probabilities 0.2% asterisk 0.002% equals 0.4%. That's 4 in a million. Or to put it another way, roughly 1 in 250,000. But we're still not done because there's a third factor. The trajectory isn't just passing near Mars and Jupiter, it's doing so in a way that maximizes observational opportunities. The closest approach distances are neither too close nor too far. Too close and the object would zip past before instruments could properly observe it. Too far and the resolution would be inadequate. The distances 3.2 Atlas maintains are frankly ideal for spacecraft observation. When you factor in the optimization of approach distances, the combined probability drops even further. Javlobo has calculated it at approximately 0.005%. That's 5 in a million. 1 in 200,000. Think about what 1 in 200,000 means. If you shuffled a deck of cards and dealt yourself 5 specific cards in a specific order, that would be more likely than this trajectory occurring by chance. If you bought a lottery ticket, you'd have better odds of winning a substantial prize than 3i Atlas has of randomly following this path. Now, let's talk about the 5 degrees tilt, because this is where the mathematics becomes even more intriguing. Why 5 degrees? Why not perfectly aligned at 0 degrees? Why not 10 degrees or 20 degrees or some other random value? There's a hypothesis that explains this, and it's elegant enough to be disturbing. It's called the transit survey cone theory. Here's how it works. Imagine you're an alien civilization on a planet orbiting a star somewhere in the galaxy. You want to detect other planetary systems. How do you do it? The same way human astronomers do it. Transit surveys. You watch stars and wait for planets to pass in front of them, causing tiny dips in brightness. It's the most successful method we've developed for finding exoplanets. Thousands of worlds discovered this way. But here's the catch. You can only detect planets that transit your star from your perspective. If you're not in the right alignment, if you're not looking at the star from the right angle, you won't see the transit. The planet could be there, but you'd never know it. This means there's a narrow cone of space, a specific viewing angle from which our solar system's planets would be detectable via transit survey. If an alien civilization is located within that cone, they could detect Earth, they could detect Mars, they could detect Jupiter. They'd see all 3 crossing the face of our Sun from their vantage point. How wide is this cone? It depends on what you're looking for. If you only care about detecting Earth-sized planets, the cone is quite narrow, maybe a degree or 2. But if you're interested in detecting everything, including the asteroid belt, which creates a thick torus of debris between Mars and Jupiter, the cone expands significantly. The asteroid belt is about 150 million kilometers thick. From a distant vantage point, objects transiting the Sun from anywhere within that belt would be detectable. The mathematics work out to a cone approximately 10 degrees wide. Any civilization located within that 10 degrees band above or below the ecliptic plane would be able to detect our asteroid belt, our major planets, and Earth. They'd know this solar system is worth investigating. Now, if you were that civilization and you wanted to send a probe to investigate our system, what trajectory would you use? You'd launch it along the same alignment. You'd send it straight down the center of the cone that gave you the detection in the first place. That trajectory would be inclined at 5 degrees dead center, halfway between 0 and 10. 3i Atlas is inclined at 4. 89 degrees, essentially 5 degrees, accounting for measurement precision. This could be coincidence, but its very specific coincidence is not just roughly aligned, is aligned in a way that makes perfect sense if the object were deliberately targeted at our solar system by a civilization that detected us via transit survey. The mass of 3 Atlas adds another layer to this puzzle. Based on brightness and estimated size, the object mass is at least 33 billion tons, possibly more. For comparison, the International Space Station, humanity's largest space structure, mass is about 420 tons. The Space Shuttle, when fully loaded, was about 2000 tons. SpaceX's Starship, the largest rocket ever built, is 500 tons at launch. 3I Atlas is 6 million times more massive than Starship. 6 million. If this object is artificial, if it was constructed rather than naturally formed, the engineering required is beyond anything in human capability by factors that make the comparison almost meaningless. We're talking about a civilization that can manipulate billions of tons of material, accelerate it to interstellar velocities, and send it on trajectories precise enough to thread the needle between planets separated by hundreds of millions of kilometers. That's the level of technological sophistication implied if 3 Atlas is a probe, not just beyond us, incomprehensibly beyond us. The difference between a stone axe and a particle accelerator. Lower's compiled what he calls the 7 anomalies of 3 Atlas. The trajectory is anomaly 6, but it's the one that ties everything together because the trajectory determines everything else. Where the object goes, what it encounters, when it encounters it, if the trajectory is deliberate, if it's targeted, then every other anomaly needs to be reconsidered in that context. A natural comet with an unlikely trajectory is a curiosity. An artificial probe on a carefully calculated trajectory is something else entirely. It means someone pointed this thing at us. It means someone wanted it here. It means someone is or was interested in our solar system specifically. The probability calculations don't prove anything. 1 in 200,000 is unlikely, but it's not impossible. Unlikely things happen. People win lottery eyes. Lightning strikes the same place twice. Cosmic coincidences occur, but when you're a space agency, when you're NASA or ESA or CNSA and you're looking at data from October 3rd and you're seeing something with a 1 in 200,000 trajectory doing something unexpected, something that doesn't quite fit the comet model, you start asking questions, hard questions. Questions about whether you should publish the data immediately or whether you should take some time to understand what you're looking at. Questions about whether the trajectory is trying to tell you something. Questions about whether whoever or whatever sent this object, if anyone did, intended for us to notice, intended for us to wonder, intended for us to ask exactly these questions. The mathematics don't lie. The trajectory is what it is. The probability is what it is. 1 in 200,000. Those are the numbers. What the numbers mean, what conclusion we draw from them, that's the question keeping astronomers awake. And somewhere in the data from October 3rd, somewhere in the images we haven't been allowed to see, there might be an answer of an interstellar object randomly arriving with an orbital plane within 5 degrees of the ecliptic. About 0.2% 2 in a 000, already quite unlikely. But we're just getting started. Now, at the timing, 3I Atlas didn't just cross the ecliptic plane, it crossed it at precisely the right locations to encounter Mars and Jupiter. Think about what that requires. Mars orbits the Sun at an average distance of about 230 million kilometers. Jupiter orbits at about 780 million kilometers. For 3I Atlas to pass close to both planets, it needs to cross their orbital paths when the planets are actually there, not on the opposite side of the Sun, not months ahead or months behind, right there, right when the object passes through. Chapter 6, October 29th, The Hidden Moment of Truth. There's a date circled on calendars in observatories around the world. October 29th, 2025, 22 days from now. That's when 3 Atlas reaches perihelion, its closest approach to the Sun, 1.36 astronomical units, about 203 million kilometers just inside the orbit of Mars, just outside the orbit of Earth. And here's what makes this date so critical, so potentially revealing and so frustratingly inaccessible. 3I Atlas will be completely hidden from every telescope on Earth. The geometry is simple but unavoidable. As the object approaches perihelion from Earth's perspective, it will be moving toward the Sun. Then it will pass behind the Sun. Then, if everything goes as expected, it will re-emerge on the other side in late November. But during that closest approach, during the period when solar radiation is at its most intense, when the comet should be at its most active, when anything unusual is most likely to happen, we won't be able to see it. The Sun will be in the way, literally between us and the object we're trying to observe. This is more than just inconvenient. It's a critical gap in our observational timeline because perihelion is when comets reveal their true nature. When they're far from the Sun, they're cold, inert, dormant. The volatiles, the frozen gases locked in their ice stay frozen. There's minimal outgassing, minimal activity. They're just dark chunks of material drifting through space. But as they approach the Sun, as solar radiation intensifies, everything changes. The surface warms, ice begins to sublimate, transforming directly from solid to gas without passing through a liquid phase. This releases jets of vapor and dust. The coma expands, the tail forms. The comet comes alive in a very real sense, driven by the energy pouring into it from the Sun. At perihelion, this activity reaches maximum intensity. The surface temperature can climb high enough to vaporize materials that were stable just weeks before. Complex organic molecules break down. Subsurface ice exposed by surface erosion starts venting. If a comet is going to fragment, if it's going to split apart under thermal stress, perihelion is when it happens. For 3I Atlas, perihelion represents approximately 12 gigawatts of solar power hitting its surface. To put that in perspective, that's the output of about 12 large nuclear power plants constantly for hours, focused on an object only a few kilometers across. The thermal load is extraordinary. The stresses are enormous. If 3 Atlas is a natural comet, we should expect specific things to happen. Massive outgassing, a dramatic brightening as more surface area becomes active, a well-developed tail streaming behind it as solar wind pushes the released material away from the Sun, possibly fragmentation if there are structural weaknesses in the nucleus. This is standard comet behavior at perihelion. We've seen it countless times with solar system comets. But if 3E Atlas is something else, if there's any validity to the artificial origin hypothesis, perihelion might reveal very different behavior. And this is where things get uncomfortable for the wait-and-see approach. There's a maneuver in orbital mechanics called the Earth effect. When you're near a massive object, when you're deep in a gravity well, any change in velocity has amplified effects on your orbit. Spacecraft use this routinely. You wait until you're at closest approach at perihelion if you're near the Sun, and then you fire your engines. The velocity change achieved at perihelion translates into massive orbital energy changes. It's the most fuel-efficient way to alter an orbit significantly. Now, if 3I Atlas wanted to change its trajectory, if it wanted to decelerate and become gravitationally bound to the Sun rather than continuing on its hyperbolic escape trajectory, perihelion is when you do it. You'd wait until you're behind the Sun, hidden from Earth-based observation, and you'd perform what's called a reverse solar Orth maneuver. You'd slow down, and instead of shooting past the Sun and leaving the solar system, you'd drop into an elliptical orbit. You'd stay. Alabi has pointed out that the timing is optimal for exactly this maneuver. The object would be obscured from Earth. The thermal and radiation environment around perihelion would mask any propulsion signatures. If you wanted to hide a trajectory change, this is when and where you do it. Moreover, if 3 Atlas is a mothership, if it's carrying smaller probes designed to be deployed toward inner system targets like Earth or Venus, the retrograde orbit makes perihelion the ideal deployment point. The object is moving opposite to planetary orbital motion. A probe released at perihelion with minimal velocity could intersect Earth's orbit with relatively little energy expenditure. The planet would in effect run into the probe as both objects orbit the Sun in opposite directions. This is the Trojan horse scenario. It looks innocent. It looks like a comet passing through doing what comets do. But at the hidden moment, a perihelion when nobody can watch, it does something else. It deploys, it maneuvers, it reveals purpose. Now, does anyone actually think this is likely? Most astronomers would say no. Most planetary scientists would argue that 3 Atlas will behave exactly like a comet should, that it will brighten and outgas and possibly fragment, and that when it re-emerges in late November, we'll see exactly what we expect to see. A comet that survived perihelion and is now heading back out toward interstellar space. But the fact that we can't observe it during this critical period bothers people. It bothers them enough that multiple professional observatories have made plans to observe the re-emergence in late November with unusual intensity. It bothers them enough that space agencies are coordinating to have instruments ready the moment 3 Atlas becomes visible again. Because here's the uncomfortable truth. If 3 Atlas goes behind the Sun as one thing and comes out as something else, we'll have missed the transformation. We'll have before and after, but no during. We'll know something changed, but we won't know how or why or what exactly happened in those hidden hours. There's a philosophical parallel here. The thought experiment about the tree falling in the forest. If an interstellar object does something unusual at perihelion and nobody can observe it, did it really happen? But that's not quite right, because we'll know by what comes after. If 3I Atlas re-emerges in late November on a different trajectory or with different properties or accompanied by smaller objects that weren't there before, we'll know something happened. We just won't know what we're supposed to call it. The October 3rd data. The images we haven't seen might provide context for this. If those images showed something unexpected, something that suggests 3 Atlas isn't behaving like a typical comet, then what happens at perihelion becomes exponentially more important. It becomes the moment when we either get confirmation that this is just an unusual natural object, or we get something that forces us to reconsider everything. 22 days, 3 weeks, and a day. That's how long until this hidden moment arrives, until 3I Atlas disappears behind the Sun, and we lose our ability to watch what happens next. Until we enter a period where we have to wait and wonder and hope that when the object re-emerges, it's still just a comet heading home to interstellar space. Hope that it hasn't changed. Hope that it hasn't stayed. Hope that whatever these 7 spacecraft saw on October 3rd was interesting but explainable. And that perihelion will be equally interesting and equally explainable. But hope isn't data, hope isn't observation. Hope is what you rely on when you don't have the information you need to draw conclusions. And right now, as the silence from space agencies continues, as the days count down to perihelion, hope is mostly what we have. That and the knowledge that in late November, when 3I Atlas re-emerges, we'll finally know if our hope was justified. Chapter 7, The Nickel Without Iron Smoking Gun. Of all the anomalies associated with 3E Atlas, there is one that stands apart from the others. One that astronomers find genuinely difficult to explain away with natural processes. One that, when you understand the underlying physics, makes you stop and reconsider everything you thought you knew about this object. It's the nickel, or more precisely, the nickel without iron, Let's start with some basic cosmic chemistry. When massive stars die, when they exhaust their nuclear fuel and collapse into supernovae, the explosion creates heavy elements through nuclear fusion: carbon, oxygen, silicon, and yes, metals like nickel and iron. These elements are forged in the extreme temperatures and pressures of the supernova core, then blasted out into space where they eventually become part of new star systems, new planets, new comets. Here's the critical point. Nickel and iron are created together. They form in the same stellar layers during the same nuclear processes. They have similar atomic structures. They bond together in similar ways. In nature, in every natural object we've ever studied, from meteorites to asteroids to comets, nickel and iron appear together, always. The ratio varies depending on formation conditions, but they're always both present. Finding one without the other is like finding smoke without fire. Doesn't happen naturally until 3 Atlas. In July and August of 2025, the Very Large Telescope in Chile conducted spectroscopic observations of 3I Atlas. Spectroscopy works by analysing the light coming from an object. Different elements absorb and emit light at specific wavelengths, creating a unique fingerprint. You can identify what an object is made of by looking at these spectral lines. The VT detected 22 distinct emission lines of nickel in the gas cloud surrounding 3I Atlas. 22. That's not a subtle signature. That's a strong, unmistakable detection. The comet was producing neutral nickel atoms in its coma, releasing them as gas vaporized from the surface. But here's the problem. Iron emission lines, 0. Nothing. Complete absence. The instrument was sensitive enough to detect iron if it was there. Other comets observed with the same equipment show both nickel and iron, but 3I Atlas showed nickel and only nickel. To understand why this is extraordinary, you need to understand the temperature problem. At the distances where 3-2 Atlas was observed between 3.8 and 2.8 astronomical units from the Sun, the surface temperature is far too low to vaporize solid metal. Nickel has a melting point of 1455 degrees C. Its boiling point, the temperature where it vaporizes into gas, is 2913 degrees. A comet's surface at 3 astronomical units doesn't get anywhere close to that. It might reach a few dozen degrees above freezing, maybe 100 degrees C in direct sunlight, not 2900. So, how is 3I Atlas producing nickel gas? The standard explanation for comets is that the nickel isn't vaporizing directly. It's trapped in other compounds, carbonyl compounds, that can sublimate at lower temperatures and carry the metal atoms with them. When these compounds break down in sunlight, they release the metal. It's called the nickel carbonyl channel, and it's been proposed as a mechanism for how comets can show metal emissions despite low surface temperatures. Fine, that explains nickel, but it doesn't explain the absence of iron, because iron forms similar carbonyl compounds. If the process is releasing nickel, it should also be releasing iron. The chemistry isn't selective. Both metals should appear in similar ratios to their abundances in the comet's composition. Unless 3I Atlas has no iron, or unless the nickel to iron ratio is so skewed, so dramatically different from anything natural that effectively only nickel is detectable. Here's where it gets even stranger. The nickel production wasn't constant. It was increasing dramatically. Between July and August, as 3-2 Atlas moved from 3.88 astronomical units to 2.85 date 5 astronomical units, the nickel emission rate increased 25-fold, 25 times more nickel in just 1 month. That's an exponential ramp-up far steeper than normal cometary outgassing patterns. By late August, 3I Atlas was releasing nickel at a rate described in the scientific literature as extreme. The production rate was higher than any comet ever observed at comparable distances from the Sun, and it was accelerating as the object approached perihelion. Now let's talk about what this signature means on Earth. when humans want to purify nickel industrially, when we want nickel without iron contamination, we use a process called the bond process or the carbonyl process. You expose nickel or to carbon monoxide at specific temperatures. The nickel reacts to form nickel carbonyl, a volatile compound that can be separated from the iron-rich, or then you decompose the nickel carbonyl at higher temperatures to get pure nickel metal. It's the standard industrial method for producing high-purity nickel. It's used in metallurgy, in manufacturing, in any application that requires nickel alloys without iron contamination, and it produces exactly what 3.2 Atlas is showing, nickel emission without corresponding iron emission. This doesn't prove 3I Atlas is artificial, it doesn't prove someone built it, but it does mean that the chemical signature we're seeing from this object matches an industrial process better than it matches any natural process. The spectrum of 3E Atlas looks more like a nickel refinery than a comet. Could there be exotic natural chemistry that produces this? Possibly. Maybe conditions during formation in another star system might create metal ratios we've never encountered. Maybe the nickel carbonyl channel is somehow selective in ways we don't understand. Maybe there's a physical process involving magnetic fields or electrical discharges or something else that preferentially releases nickel over iron. But here's the challenge for that argument. We've observed a lot of comets, hundreds from our solar system, and now 3 interstellar visitors. Not one of them, not a single one, has shown this nickel without iron signature. If it's a natural process, if it's just weird chemistry from a weird formation environment, why are we only seeing it now? Why is 3 Atlas the exception? The scientific paper analyzing the VT data uses careful language as scientific papers should. It describes the observations as extremely puzzling. It notes that the presence of nickel and iron in cometary coma is already unexpected given the low temperatures. It acknowledges that 3I Atlas exhibits extreme properties regarding the production rates and abundance ratios of these metals. But it stopped short of saying what everyone reading the paper is thinking. This doesn't look natural. This looks engineered. Avi has been more direct. He stated publicly that the detection of nickel without iron is a signature known to exist in industrially produced alloys made through the carbonyl chemical pathway. He's argued that while a natural explanation might exist, the burden of proof now shifts to showing what that natural explanation could be. Because right now, the simplest explanation that fits the observed data involves artificial nickel production. Which brings us back to the silence. If you're a space agency, if you've got spectroscopic data from Mars orbiters during the October 3rd flyby, you've almost certainly analysed the chemical composition of 3 Atlas at much closer range than the VT observations. You've got better resolution, better sensitivity, more detailed spectra. What did those spectra show more nickel, still no iron? Did the ratio get even more extreme at closer observation? Did you detect other elements, other compounds, other signatures that make the industrial interpretation more or less plausible? We don't know, because that data hasn't been released. The VT observations from July and August are public because they came from a ground-based telescope operated by an international consortium that publishes its data according to standard scientific protocols. But the Mars spacecraft data that goes through different channels, channels that can be paused, channels that can be controlled. The nickel signature is the smoking gun. Not definitive proof, not absolute certainty, but the strongest single piece of evidence that 3 Atlas might be something other than a natural comet. And somewhere in the October 3rd data, there are observations that either confirm this signature or contradict it. Observations that might show even more extreme metal ratios or might show that at closer range, the iron finally appears and everything normalizes. Either way, those observations exist and we're not being allowed to see them. Chapter 8. the 7 anomalies connecting all the dots. We've been circling around individual pieces of this puzzle: the trajectory, the nickel signature, the coordinated silence. Now, it's time to look at the complete picture, because 3 Atlas doesn't have 1 anomaly, it has 7. And when you stack them together, when you see how they interconnect, the cumulative weight becomes difficult to dismiss. Anomaly 2, the Ford jet, when Hubble Space Telescope captured 3I Atlas on July 21st, 2025 something immediately caught astronomers' attention. The object had a visible jet of scattered sunlight extending ahead of it, not behind it, which is where comet tails normally appear. Ahead pointing toward the sun, the jet was 10 times longer than it was wide, a narrow focused stream of material. And here's the strange part. For weeks after that Hubble observation, no proper tail developed, the typical comet appearance, a bright head with a long tail streaming behind as solar wind pushes gas and dust away from the sun. Didn't show up until late August, almost 2 months after discovery. Normal comets develop tails as they approach the sun. The closer they get, the stronger the solar wind, the more pronounced the tail. But 3-2 Atlas had this forward jet first, a jet pointing in the wrong direction, a jet that looked more like exhaust from a nozzle than natural outgassing driven by solar heating. By late August, a weak tail finally appeared. The comet started looking more like a comet. But that initial forward jet, that 10:1 aspect ratio, that unusual directionality, it's not typical, it's not impossible, but it's not what you expect to see. Anomaly 4, the carbon dioxide dominance. When NASA's James Webb Space Telescope and the Sphere-X Observatory analyzed 3 Atlas in August, they detected something remarkable. The gas cloud surrounding the object, the coma, is 95% carbon dioxide, only 5% water. That's an 8:1 ratio. Carbon dioxide to water. Compare that to comets from our solar system, which are typically water dominant. Most comets are closer to 1:1 or even favour water over carbon dioxide. An 8:1 ratio in the opposite direction is extraordinary. Now, carbon dioxide ice sublimates at lower temperatures than water ice. Dry ice, as we call it on Earth, turns to gas at -78 degrees at standard pressure. Water ice requires 0 degrees. So a carbon dioxide-rich comet would start showing activity farther from the sun than a water-rich comet, which actually matches what we observed with 3 Atlas. It was active at 4.4 astronomical units much farther out than typical comets wake up. The question is, why? Why would 3E Atlas have such an unusual composition? The answer probably lies in where it formed. Different regions of the galaxy, different protoplanetary disks, different ice lines around different types of stars. All of these factors affect what materials condense and what ratios they end up in. 3 Atlas likely formed in an environment very different from our solar system's formation region. Perhaps around an older, cooler star. Perhaps in a region with different elemental abundances. But here's where it connects to the other anomalies. Carbon dioxide isn't just a different volatile, it's a propellant. If you wanted to maneuver a spacecraft using cold gas thrusters, carbon dioxide would be an excellent choice. It's stable. It's easy to store. It sublimates at accessible temperatures. And a spacecraft carrying large reserves of carbon dioxide ice could maintain a comet-like appearance while having plenty of material for trajectory adjustments. Is that what we're seeing propellant reserves masquerading as natural volatiles, or just unusual cometary chemistry? The composition alone doesn't answer that, but combined with the trajectory, combined with the nickel signature, it's another data point that fits both natural and artificial interpretations. Anomaly 5, the extreme negative polarization. This one requires understanding how light behaves. When sunlight reflects off a surface, it can become polarized, meaning the light waves align in a particular direction. The degree and type of polarization tells you about the reflecting surface, its texture, its composition, its structure. 3 Atlas shows extreme negative polarization. The polarization measurements are outside the normal range for comets, significantly outside. This suggests the surface properties or the properties of the dust grains in the coma are unusual. Different shape, different composition, different structure. Negative polarization can occur with certain types of particles, very small grains, unusual minology, specific shapes and alignments. But extreme negative polarization, that's rare. That requires explanation. Some researchers have suggested this might indicate the presence of unusual minerals formed in the environment where 3E Atlas originated. Others note that artificially manufactured particles, particularly certain types of engineered materials, can produce strong negative polarization. It's not conclusive either way, but it's another property that doesn't quite fit the typical comet profile. Anomaly 7, the WOW signal alignment. On August 15th, 1977, the Big Ear radio telescope at Ohio State University detected a strong narrowband radio signal at 1,420.4 MGHz, the hydrogen line frequency. The signal lasted 72 seconds. It was so unusual, so potentially significant that astronomer Jerry Ayen wrote, "Wow." In the margin of the computer printout, the signal has never been detected again, never repeated, never explained. The signal came from the direction of Sagittarius. Right. Ascension 19 hours 25 minutes. Declination minus 27 degrees. That's the general direction toward the center of our galaxy where hundreds of billions of stars crowd together in the galactic bulge. Now, here's the uncomfortable coincidence. When you trace 3I Atlas's trajectory backward, when you calculate where it was in 1977, it was at approximately 600 astronomical units from Earth. And its position in the sky at that time was separated by only 9 degrees in right ascension and 8 degrees in declination from the WOW signal origin. 9 degrees out of 360 degrees around the sky. The probability of this alignment being random, about 0.6%. 6 in 1,000. Could 3-2 Atlas have transmitted the WOW signal if it was at 600 astronomical units? The power required would be between half a gigawatt and 2 gigawatts. That's the output of a typical nuclear reactor on Earth. Significant power, but not impossible. And the signal was blue shifted, indicating the source was approaching Earth, which matches 3I Atlas's trajectory. The WOW signal might have been a radar pulse, a scanning beam sweeping through space, pinging nearby star systems to detect planets. And we happened to be in the beam for 72 seconds as it swept past. If 3 Atlas detected planets in our habitable zone during that sweep, it might have adjusted its trajectory slightly, accelerating to reach us sooner. By the time it arrives in 2025, it's been travelling for 48 years since that 1977 detection. All the alignment is pure coincidence. 6 in 1,000. Unlikely, but not impossible. Another data point that can be interpreted either way. Here's what all 7 anomalies tell us when viewed together. Individually, each can be explained. The size might be a statistical fluke. The forward jet might be unusual outgassing geometry. The nickel signature might be exotic chemistry. The carbon dioxide dominance might be formation environment. The polarization might be odd dust properties. The trajectory might be random chance. The WOW signal alignment might be coincidence. But all 7 together. That's when the natural explanation starts to require more and more caveats. More and more unlikely circumstances that all happen to align in the same object. It's not impossible, but it's improbable. And the more you stack on, the more improbable it becomes. Avibi has assigned 3 Atlas a ranking on his lobe scale. The scale goes from 0, definitely natural, to 10, definitely artificial and potentially hostile. He currently ranks it between 2 and 4, not 0, Not natural by default, but not high enough to declare anything definitive. Right in the ambiguous middle, where you need more data to make a determination. And that's where we are. That's where we've been since October 3rd, in the ambiguous middle, waiting for data that exists but hasn't been released, waiting for space agencies to break their silence, waiting to find out if those 7 anomalies, when examined at close range by 7 spacecraft, get explained away by natural processes, or if they get reinforced by additional observations that make the artificial hypothesis harder to ignore. The data exists, the observations were made, the analysis has been conducted. Somewhere people know whether these anomalies resolve or intensify under close scrutiny. They know what the October 3rd images show, they know what the spectra reveal, they know what the thermal signatures indicate. They know, and they're not telling us. Not yet.